Okay, all right. Before we start, I got one question for all of you. All right. Do you know your ABCs? Okay, all right. Let's go. Okay, here's what we're gonna do for the next few days. Okay, now, going back to the graph, right? The quadratic graph, the U-shaped graph, right? Remember how we were looking for the several of the definitions, right? So, for example, we were looking at the vertex, minima, maxima, axis of symmetry, all that sort of stuff, right? And now, we were very, very reliant. We were exclusively reliant on the graphing calculator to help us do that, right? So what we're gonna do today then is, this week, is talk about how to find those same things without ever using a graphing calculator, without ever relying on a graph, okay? Because that's actually possible. Now, before we do that, right? Like the question I asked you at the intro, right? Do you know your ABCs? One of the things I want to revisit right now is to simply look at, hey, what does a quadratic function look like again, right? So I'll give you an example, right? Your really, really typical, right? Basic quadratic function might look something like this, right? I don't know, I'm just writing random stuff, right? Might look something like this, right? And with the focus on this here. What I need to get across today is that the coefficients for each of the terms, right, or in this case, a constant, right, of the terms, right, plays a very large role for the next month, all right, of this unit, okay? It's so, how do I say it? It's so pervasive, all right? This idea of using the coefficients of each of the terms of a quadratic function, that we're gonna spend a day just on doing this. Because if you don't understand this particular part from today, it's gonna be really difficult. Not today, but in a month, it's gonna be really difficult for you to be able to operate on some of the ideas that you're gonna learn in class, okay? So with that said, let's go. Now, if we were to look at this, this quadratic function, right? You realize that each of these has a number in it. So what I want to show you then is to kind of take a step back and show you the generic version of a standard form quadratic function, right? So here, in a very standard quadratic function, right, we got our x squared, right? That's the most important thing, right? That's what makes it quadratic. We got the middle term here. By the way, there's a name for this. So this is the quadratic term. This is the linear term, right? And why is it linear? Because if I were to cover this up, now how can I cover it up? I don't know how to cover this up. If I were to use a whiteout, right? Let's see. If I were to cover this up, what you end up here is just a linear function, right? Mx plus b. Remember that, right? Bx plus c, mx plus b, same thing, right? So what I want to show you then is the idea that, right, if we don't put numbers in there, a, b, and c, I should use green, yeah. A, b, and c are just numbers, okay? Get that? All right, so A, B, and C, they're just numbers, and it could be any combination, right? So in this very case, the first coefficient, the leading coefficient, as a matter of fact, is 1, right? Here, the coefficient of the middle term is 1, and the constant is 6, right? So far, so good, okay? Now, I gotta erase this just to make it easier for you guys to see this while we're doing it. So let me give you a couple of examples of what my expectations are, all right, for today. So, okay, now here we go, all right? Looking at this example, right? If I were to ask you, and this is all I'm asking you, okay? And I know what some of you might say, all right? Mr. Engler, you're gonna spend a day with us on this. This is so easy, all right? You just wait and see, all right? In a month, all right, it'll be totally different. Hold on, the light just went off again. All right, now, What's A? Well, let's match, right? A, right? First number, so that's 3. What's B? That's 4. What's the constant? 2. That's it. All right? That's all I need you to be able to identify. All right? So what about this one? I'll just write underneath. A is what? 5. What's B? 2. No. -2. Right? What's C? 9. No. -9. Okay? Got that? Now, let's try a couple more because these are easy to do. All right? A, what's A here? Yep, -1. What's B? 6. What's C? 18. All right? So far, so good. What's A here for this next one? Yep, 1. Right? What's B? -1. Right? And what's C? -3. All right, so far so good. All right, let's kick it up a notch. All right, so here we got x squared minus 16. So what's A? 1, right? What's B? -16. No, it's not. That's the constant, right? The constant is -16 because that's just a number, right? That's this part. So what's B then? Let me ask you. Looks like, because look, I mean, if I were to rewrite this, you got x squared, and I got a blank in the middle, -16 equals 0. So what do you think goes in the middle right here? Yeah, plus, right? We got x, right? You still put x in there. But what does that coefficient have to be if it is supposed to have nothing in the middle? Yeah, 0. So B is 0. Okay, so if I were to write this, it would look something like this. Right? If I really want to write in standard form, the only exception is no one writes 0x. It's just nothing, right? So all you have is x squared minus 16. All right? So you see why I have to do that, show you that? Okay, what about this one? What's A? Yeah, 3, right? What's B? Nothing, right? Because there's no x term here. There's no middle term in here, right? So B is again 0. What's C? Yeah, -36. Okay, all right, so far so good. What about this one? What's A? Yeah, 1, right? Because that's the invisible 1 here, right? And then B is -7. What's C? Yeah, it's nothing, right? Because there's no constant term here, so 0. All right, last one, and then I'll let you practice. A is 2, B is 8, C is nothing. Okay, all right, so far so good. All right, now try some of these on your own. These 5 questions, all right, let me help you out a little bit. Let me put the generic formula on the side there too. Hold on. All right, I'll put this on the side here, on the corner. All right, so go ahead, take a couple of minutes, press pause right now, and then we'll go from there. Okay, so press pause right now. Okay, all right, and we're back. Okay, so there we go. This is it. I decided to show you the answer key because it would just take too much time for me to go over something like this with you. Okay, now since we got a little bit of time, let me just go ahead and show you this. So here's why we need to know this. Okay. Very important, like it's not gonna do this for no reason, okay? So here, all right, so here's the question. How to find the vertex and the axis of symmetry without graphing. So this is actually the lesson today, all right? Everything I just shown you in the last 2, all right, it's like that scene from the Karate Kid, you know, when Daniel-san had to, keep waxing the car, right? So that's what that was, all right? So that was our Karate Kid moment. Now, we're actually gonna be here to take a look at the actual business of solving these questions. Okay, so now, first thing I want to emphasize is, right, how do you find the vertex and the symmetry? This is the formula, all right? And this formula will give you the x coordinate, all right? Which is what we need, right? Because all the lines of symmetry, hold on, let me go get something, just so that I can show it to you. Give me one moment, all right? I might just show you this and then end the lesson, okay? So hold on one second. Okay, all right, and so I went back to the notes from earlier and found this, right? So let's take it all again, right? Axis of symmetry, it has to be x equals something, all right? So let me write that down, right? This axis of symmetry always has to be x equals to something, right? Now, as a result, our vertex also relies on the x value because the axis of symmetry and the vertex shares the same x value, right? Now, that have been established already in the earlier lesson with you guys, okay? Okay, all right. Now, what does this formula tell you, right? Because it's like, okay, like you just give me negative b over 2a. There's no x, right? The x is on one side. There's no y. There's no nothing, right? Not true. So let's take a look, okay? Now, this is the formula. I don't think this is given, okay? So you're going to have to know this, all right, for the regions. So again, x equals to negative b over 2a, all right? Now, that's just the beginning, by the way. We have like... we're gonna be working with formulas that has like, you know, show these letters like over and over again. All right. So now vertex. Let's find the. Actually, we should find the axis of symmetry first. Actually, because that's the easiest thing to get to. All right. No. So what's the axis of symmetry? Right. X equals what? Well, x equals to negative b over 2a. Right. Which means negative. Now you tell me, what's a? What's b? What's c in this expression? What's a? Yeah, 1, right? The invisible 1 here. What about b? 4. What's the constant term? C. Yeah, 1. You see why we have to do that just now, right? Because otherwise, there's just no way we can navigate through this lesson and this formula. All right, now, let's take a look then. Now we just, like, good old substitution. Negative, right? b, which is 4. Over 2a, which means 2 times 1. See that? So that's negative 4 over 2, which is negative 2. Now, let's see if this is right. So I'm going to use my graphing calculator just to make a point, all right? So my graphing calculator, I'm going to plot this in x squared plus 4x plus 1. X squared plus 4x plus 1, and I'm going to graph that. Should be okay. Yeah, right? Now, what did I just say about the axis of symmetry, right? X is equal to negative 2, right? Look, x is negative 2. There's your symmetry. All right, and if you don't, at this stage, if you still don't trust me, I can trace it, right? I could trace the minimum, right? So I could go like this. Not that, I doubt that there's a single person here that doesn't trust me, okay, with that. So, right? Yeah, negative 2, right? X is negative 2. Now, luckily enough, by doing this, I also found the minima, right? The vertex, right? So now, so we know we're right about this. So what's the vertex, right? The vertex is therefore then, right? Now I have to start with a negative 2. You know that, right? What's the vertex? Well, it's negative 2, so that means, now, once we found the axis of symmetry to find the vertex, all we have to do is substitute, right? Because I need to know what the y value is, right? So in other words, let's go back to the graph, right? If this has to be at negative 2, what would y be? Easy, just substitute, right? So again, I know I'm using a graphing calculator right now, but what I'm trying to emphasize in this lesson is that, are we out of time? Yeah, almost. What I want to emphasize in this lesson is that if they're telling you that you cannot use a graphing calculator to find the axis of symmetry of vertex, this is what you can do. Okay, now let's substitute then. So here I'm just going to substitute right underneath this. So that's negative 2 squared plus 4 times negative 2 plus 1, right? Now what's that? Negative 2 squared is positive 4 minus 8 plus 1. So that would be negative 4 plus 1, that would be negative 3, right? So the vertex is negative 2, negative 3, and it was true because it was on the graphing calculator before, right? I'll show it to you again, just in case you don't believe me. Okay, I know everyone believes me. All right, okay. I just want to have an excuse to show you this. All right, right? Negative 2, negative 3. There's our minimum, right? There's our vertex. Negative 2, negative 3. So far, so good. Now, what about the y-intercept? Meaning, right, y-intercept is this. Meaning, when x is equal to 0, what would y be? So how do you think we can find that? Yeah, substitute 0 in there. So watch this, right? 0 squared plus 4 times 0 plus 1. Right, so that's 0, 0, 1. So y-intercept is just 1. Is that right? Hold on. 0, 0, I did that a little too fast. 1, so that means the y-intercept is 0, 1. Let's see if that's even true. All right, and that's actually true, right? Where does the blue quadratic function cross the y-axis? Right here, right? Now, you can look at the table of values too. So look at the table of values. When x is 0, y is 1. There you go, right? So, see, I didn't lie to you. All right, so there we go. Okay, so we got our 3 answers. All right, now, let's make sure you lock in this knowledge for today. So let's do one more example together. So give me 1 second. Let me go find an example. All right, now one more example, and then what we're going to do tomorrow is just practice like crazy, okay? So, all right, now, let's see. So I found this from notes from earlier in the month. And so what I'm going to do is this, all right? I'm going to graph this first. All right, I'm gonna set the stage. So hold on, let me graph this first. And then what we're gonna do is, as we go over the vertex, the axis of symmetry, and the y-intercept, we can refer back to the graph just to show that what we're doing is right, okay? So if you ever wanna use that as a strategy to check your answers, you're more than welcome to do that. Now, what's the question? X squared minus 2x minus 8, all right, 2x minus 8. All right, I'll graph it and then we'll go from there. All right, okay, there's our graph and the lights just went off again. Hold on. All right, now let's see. Okay, all right, let's actually do the work here. So here, let me make sure I'm still recording. Good. All right, so here we gotta look for those 3, right? The vertex, the axis of symmetry, and the y-intercept. All right, again, right? Rewrite the equation every time. Okay, if it helps you, do that. All right, so x, right, is equal to negative b over 2a. All right, that's our reference. Now, let's see. So let's see, vertex now again, right? I'm going to go for the axis of symmetry first, because the reason why we go for the axis of symmetry, because right off the bat, axis of symmetry only needs one number, right? Because vertex and y-intercept, they need a coordinate, right? They need 2 numbers. So let's always start on the easy one first, okay? So always start on the axis of symmetry. Now, let's use that equation. So negative, so now again, the other thing I would recommend is always list out the A, B, and C values, okay? So like that. A is 1, B is negative 2, C is negative 8. All right, so let's see. Negative B, so now careful here, negative of negative 2. All right, extra careful, over 2 times 1, that's 2, right? So that's 2 over 2, that's positive 1. Now let's see if the axis of symmetry is at x equals 1. Yeah, looks like it, right? It's right here. Yep, that looks good. All right, so x equals 1, circle my answer. All right, now vertex. Let's do that second. Vertex is we're going to substitute 1 in there. So that's 1 squared minus 2 times 1 minus 8. That's just 1 minus 2 minus 8. That's negative 11. So the vertex is 1, negative 11. Now let's see if that's true. Yeah, it's down there somewhere, right? 1, 2, 3, 4, 5, 6, 7, 8. 9. Am I off? Am I off just by a little? What's going on here? Hold on 1 second. Oops, it's negative 9. Yep, I had to double check. Okay, all right. Now let's see. 1, negative 9. Yeah, that's true. I just counted it, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. The minima, right? All right. Now let's see. What else I have to talk about? Oh, the y-intercept. Right? Which means when x is 0, what's y, right? So we substitute 0 squared minus 2, 0 minus 8. That's 0 minus 8. So that's negative 8. All right, let's see if that's true. Oh, wait, hold on. The y-intercept? Yeah, let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there we go, right? Right here, y-intercept, right? Where the graph touches the y-axis. Okay, so that's it. All three checked out. All right, now to summarize, I know it's a long video. To summarize, tomorrow's video is going to be much shorter, by the way, because we're just going to practice. So to summarize, what am I trying to say? In the big picture, isn't it amazing that somehow someone found this formula, discover this formula, such that if you use this properly, you can find all this information out, right, without having to use a graphing calculator. Now, I think that's pretty amazing, okay? So, all right, let's sign off here. Tomorrow we'll practice, so I promise I'm gonna make the videos shorter, all right? Hopefully much shorter, and that's it. Okay, thanks for watching. Have a good day. See you tomorrow. Bye-bye. OMG, that was so good.